Namaste. I, JVN Neha Sharma, JVWU Women's University, Department of Science and Technology, Faculty of Education and Methodology. So, our today's topic is recurrent neural network, right? So, as the name say, recurrent neural network. So, what do you mean by the recurrent neural network here? So, basically, recurrent neural networks are the type of sequence networks. So what do you mean by the sequence networks here? So let's say the example, like if you wanna translate some statement from English to French language, or to say in Hindi to Spanish language, right? So how this translation make happens exactly? So this is because of the sequence network. Behind that algo is working is sequence network algorithm, right? Either it's RNN or LSTM or GRU, it can be anyone, right? So sequence data is the text, video, speech, or stock market signal, right? So it can be anything which is in the sequence. Like in our document, the words are in sequence. There's a statement is combination of the uh, words, right? So so this kind of online translation of document is happened by the sequence network and by the RNN. So RNN is to make use of sequential information, and in a traditional neural network we assume that all input and output are independent to each other, right? But for many tasks that's very bad idea, right? If you want to predict the next word in a sentence, so here you can see the Google autofiller. How Google autofiller work? So Google autofiller also work uh, with this RNN, right? So like if you want to search something, uh, okay, so you just write the first word and the second one. There are the different suggestions are coming up in Google browser, right? So this is because of the RNN, because system rememberize your searches in the history, and then according to that, or based on that, or based on the trending searches, it gives you the output. Okay, it gives you the output. So here if you want to predict the next word in a sentence, like I type online, right? So it can be online document, online video, right? So there are different suggestions come up. Okay, so if I don't remember online with the system, so every time I have to feed the online also with the system, right? So better to rememberize the searches and the feeds which we are given to the system. So every time we don't need to feed the system again and again the same kind of inputs. So here the recurrent neural network work. So recurrent here use is because they perform the same task for every element of sequence, with the output being depend on the previous computation. So what is the meaning of this line is basically uh, right, like I said before, online. I type online in the browser. So it takes online from the previous input and then add the next word according to my previous searches. Like if I searched in past online video, so on video is on the top in searches, then audio, then many others are also. So this RNN is working on the concept of sequences, feed to the input and get the output based on the historical searches and the present searches. So basically it takes two outputs, previous output, it takes two inputs, sorry, it takes two input, previous input and the current input, right? And based on that computation, it computes the output. That's why it's called recurrent network, right? So another way to think about RNN is that they have a memory. Like if I want to remember something, I have to use my memory, right? If I have to recall it, I have to use my memory. Everything, if we want to store anything, we want memory. Either it is data or some any kind of structured or unstructured data, or any kind of uh, document. So I need memory to store something, right? So RNN system has the memory, so which capture the information about what they have been calculated so far and what they have calculated in present. So in theory, RNN can make use of information in arbitrarily long sequences, but in practice they are limited to looking back only a few steps. So here is what typical RNN. RNN are of different types like deep RNN and backpropagation time RNN, and many different RNNs are there, right? So the basic uh, of the RNN is how to train the recurrent neural networks and how recurrent neural network work in real time. Okay, so here you can see the unfold. So basically, this is the final one we get, and this is the unfolding based on the previous searches and the output. So it become the deep network. So it has many hidden layers and the input and the output layer, right? So here you can see it. Here's a loop. So this is what you can say, either feedback loop, or to say it takes current input and previous input and the current input and gave the output. Okay, so it unfolded like if I have five letters in the no, how to say, five words in a statement, right? So statement is unfolded into the five internal different these kind of networks. Okay, and each word have its output. Okay, and the combination of each word make the final statement, which we can see here. Okay, so now let's take a look how to explain, or to say, let's get the deep scenario of this kind of networks and how these networks are worked exactly in real time. So the above diagram, we can show a RNN being unfolded into a full network, right? So the final one we can see, and the final one is unrolled. Okay, and get the different previous outputs of the each word. Okay, so here network for the complete sequence we see here. So this is network of the complete sequence, or this is statement. And for example, like if the sequence we care about is a sentence of five words, so network would be unrolled in five layer neural network. So here it is unrolled in three layer because the statement has three networks. So it can unroll in three different layers. Okay, and xt is the input. Here you can see the xt at the time t. So xt is the input, right? Current input. Okay, at time is time, and x minus 1 could be one hot vector corresponding to the second word of a sentence. So here you can see xt minus 1 is the previous one. Okay, so it's the previous output. Okay, and it's the next one. Okay, so st here is the hidden statement at step t. What do you mean by st? St is basically the hidden layer input. Okay, the like here in s at time t it is st, at time t minus 1 it is st minus 1, at time t plus 1 it is st plus 1. Okay, so this one is the current, this one is past, and this one is the future direction. Okay, so or to say the next one and then add on. Okay, so this is basically unfolding, right? So this is the input, this is the hidden layer input. Okay, and we get then the to the next layer, then we get the output and go to the next layer. So it is a kind of submission of all the previous layers, and take the input of previous layer as well as input from the current node. Okay, so it is similar to feed-forward network where data is flown from left to right, except it has also connections pointing to the back because it goes to back. So here you can see it is rolling back, right? So it is also roll back if the system desire to fulfill any particular any particular situation or any particular constraint. Okay, so here we can see the recurrent nodes, right? And here you can see the input at the current step. So if we calculate, so it's the memory of the network. That's why here we add the hidden layer input also, right? Because to memorize the previous searches, we need the input also, right? So these hidden layers input is also included because of the memory. Okay, and st is what? F of uxt plus wst minus 1. So we can see here the function. So what it says, uxt plus wst minus 1. So here you can see uxt and this one. It takes both. This one, so this one is the current and this one is previous. And then add it in submission and goes in function. And function may be any kind of function. Okay, like really, TANH, and any kind of activation function we use it. Okay, so s minus 1, which is required to calculate the first hidden layer, is typically initialized to all zero. So initially हम जितने भी हमारे होंगे inputs उनको हम zero पे ही initialize करके रखें. Okay, so now, and OT is basically the output at the timestamp t. And if you want to predict the next word in a sentence, it would be a vector of probabilities across of the vocabulary. So it is the t plus one step, right? Which can, or to say, we can say the searches, right? Which comes up in future with the prediction of the previous words, or to say on the basis of the previous inputs, right? So we can get the searches. Okay, so basically recurrent neural network is work with the current input as well as the previous input, and it has a memory to memorize. So here we can take a hidden layer input also in each and every node, in each and every unfolding layer. And okay, and the output is OT, input is XT, ST is the hidden layer input, and here you can see the weight associated with it. Okay, so V is, so these are all are the weights associated with the nodes. As we all know, there are weights associated with each and every node. So these all are the weights. So basically, what are the applications of recurrent neural network? So as I already told you, it's work with online document translation, sentiment analysis. In sentiment analysis, also we have sequential data based on the sentiments and based on the mood. So it's also working like in, we can say, in fit bands. Mood prediction is also there. So how can smartwatch predict our mood? It's based on the sentiment analysis, right? So it is also the application of recurrent neural network, image recognition, right? Google Lens, or to say. So Google Lens is working on image recognition. It give you the all the characteristics and the story behind that picture in detail. So it happens because of image recognition, and image recognition is working on RNA network because image also have sequences, right? In pixels and all this. And major is NLP, natural language processing. Okay, NLP is the major application of recurrent neural networks basically, because NLP is the natural language processing. And even you see Google, Alexa, and many other Google Assistant, Siri, they all are working on the concept of NLP. They understand all language. How did the machine understand all language? Based on the natural language processing. So it processes our language into the machine system and give the desired output. Speech recognition, like if you just record the audio of something, right? So speech recognition is also there. So these are the application of recurrent neural network, right? So recurrent neural network is a very efficient neural network, we can say, because it has a memory to memorize our previous searches, calculations about the outputs, and many other kind of useful data. So it helps in predictions of the next output, right? And so we don't need to feed the input again and again to the systems. Okay, so that's why it's called recurrent. And we have to also deal with the long sequences. So there are many different sequence networks for that also, like LSTM and GRU, right? So here that's it for this class. Okay, thank you.